It's working! What's going on here? What? Henrik! €2, I think it was. Happy almost Christmas time and Santa Claus. That caught me unawares. I opened Castnote just before the stream started and it picked up immediately and it caught that. Okay, I've got to try to do things in order. I've got audio, it looks good. Okay, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Good morning! Where are we? Okay, we have some names. Good morning to Amanda, to Braze, Crispian, who has changed his YouTube handle to be... I've actually got to expand the window to see what it is. Outside the box, YT, something about long, long handles. Want long handles. Good morning, Crispian. Stephen George. Oh, which reminds me. Oh, you can't quite see it. Okay, so there's another one. So I now have a spicy pillow. I now have a spicy pillow to go on the couch upstairs. The new couch, which Tom and I picked up yesterday, provided by someone from the hackerspace, Roman, who is moving to Sweden and couldn't take all his furniture with him. Yeah, this weekend is tiring. The entire weekend so far, from like Friday afternoon, I have been rushing and doing things and moving stuff around and chores, and yeah, I'm zonked. I'm zonked, and it's okay. It's Sunday morning, so we're past halfway. Also, okay. Good morning to Henrik, David C. Relware Tap. Hey Pete. Lionel Mazels is here as well. Sharky, Any Mills, Jack's Tech, Grant is here. Cable Tie, Russell, and that's everybody that's popped up in the TTS so far. So what was that audio? The audio was...
what's the plans for this spicy stream?
Okay, we have plans. We have plans, Henrik. At least I have plans, which will probably go astray. Sorry, got to quit out of that. Pete! Member for 30 months. Thank you, Pete. Okay, so I did a thing. I did a few things. I think I alluded to this.
At Relware said, roam me or off effect.
So I have plans. Jack Sek said, but will they survive first contact with the enemy? And to that I say, they have not survived first contact with Pete. Make of that what you will. Say more. I am. David, no, you are not the enemy. Only Pete's the enemy. I am trying to figure out. Okay, so what I'm looking at right now is the chat where Pete has said, if you just read it forwards, roam meor off effect. If you read it backwards, it's emor roem kefefo, which still doesn't make sense. Is it...
My plan is to watch your cool stream and cook at the same time sweet and spicy chicken with creamy cheese egg noodles, also sour pickles.
Okay. Henrik, always with the food. Trying to make me hungry. Jack Sek said needs more coffee. Yeah, but why more? Okay. So it's more coffee. It's just that the letters are jumbled up. Okay. And Paul is here as well. Awesome. Good morning, Paul. Okay, so before the stream even started, I've got to scroll back in the chat here and figure out what's going on. When I I first suggested that we should do nerd brags, when was it? It was a few weeks ago. It was quite recent, like maybe 3 or 4 weeks ago, that I said we should do nerd brags. And the idea was just to bring to mind little wins, positive things, good things, cool things. And yeah, I'm really glad that people are getting into that. So before the stream started, where is it? That's right. Amanda said, I did get 99% for producing 2 last week at uni in my film and TV degree. That, even though you didn't say that's a nerd brag, Amanda, that should be a nerd brag. 99% on your producing 2 class. That's awesome. Oh, and then went on to say, in fact, of the 7 assessments I have done, I have 5 results back so far, and they're all 99%. That is amazing. I bet you're kicking yourself, though, that you didn't get that last 1% on any of them. I don't know if it's... I mean, 99% score is incredible. But I'm just wondering if it's if it's bothering you that that you didn't quite get 100%. They should have given you 100%. Where are we? Okay, chat. Okay, so Tabray's also said, nerd brag, finally finished building my new PC after the 15-year-old one died on me. Well, 15 years getting 15 years out of a PC, that's a good run. That PC did its duty. I think it served you faithfully and well, like an old friend. But it's cool that you've finished building a new one. I hope that works out well. Maybe 15 years of service out of that one. Crispian said, I have liquefied caffeine in hand. That can count as a nerd brag. Stephen said, nerd brag, retired my 10-plus-year-old Raspberry Pi 1 with the WLED controller in my letterbox this week. Cool. So, was the Pi 1 just doing LED work inside the letterbox? What else was it up to? Were you doing mail notifications, turning your letterbox into a push notification system instead of a polled API? Where are we? Okay, I am slowly working my way down through the chat. I am trying to catch up to the current time, but temporal displacement, linear time is overrated. Imi is here too. Okay, so good morning to Imi. I didn't see Imi in the chat, but Crispian says Imi is also there. Doing things in order. Where are we? Okay. Getting closer to the end. Okay. Henrik, I'm down to the point where Henrik said, what's the plans for this spicy stream? Need more coffee, needs a lot more bacon, definitely.
Do you live by logarithmic time then?
No, my dream is to convert the world to metric time. 10 hours a day, 100 minutes an hour, 100 seconds per minute. That's what we need. The funny thing is that by doing that, it's a long time since I've looked at this, but by doing that, if you have 10 hours in a day, it means that each hour is the equivalent of 2.4, so nearly 2.5 of our current hours, which means that the sense of scale of an hour is dramatically wrong. That would really take some mental adjustment, thinking that an hour is like a big chunk of time. And, 2 hours, 2 metric hours, would be the equivalent of an entire afternoon, not just 2 hours as we think of them now. But by dividing each of those 10 hours into 100 minutes instead of 60 minutes, it brings the length of a minute back more into like they're still longer than a normal minute, like still significantly longer than a normal minute, but they're not ridiculous. Your sense of scale would adjust to that. And then by dividing each of those minutes into 100 seconds, each of those seconds ends up reasonably close to what we can currently consider to be a second. So there would be 10 times 100 times 100 seconds in a day. Why aren't there 100 minutes in an hour? Stephen says employers will still want a 40-hour work week. Yeah, I'll still want 24 hours in a day, even if they are 2.4 times as long. Okay. Where are we? There is this ongoing chat now about crispy bacon, eggs, rice, coffee, pickles. Why do these streams turn into discussions of food? Okay, so a nerd brag from Crispian. Did timing and race calling without IMI. Oh, that's sad. At the Ballarat Drag Racing Club's final 2025 event, a huge day with over 75 entrants in several categories, including Dial Your Own. What is Dial Your Own? I have not heard of a category called Dial Your Own in drag racing. Crispian, please explain. Andy said, Andy's in the chat. A few people have joined the chat. Hang on. So, good morning to the Rat 1967. Andy, Tinker, Jordan, Paul, I've already said hello to Paul. Tech Nebulous. Amanda said, I can't find where I lost the 1% in any of the assessments. Maybe... Oh yeah, Jack's Tech said, no one gets 100% in production or arts courses. So I have heard of places / I don't know if this is like a course policy or individual lecturers or whatever, but there are certain educators, I should say, perhaps teachers, perhaps lecturers, who have a policy of never giving 100%, just making it impossible to achieve. So maybe that is part of the deal. It could be that they, in the course that you are doing, they have a policy that you never actually get 100%. So you may have done it perfectly, exactly, and still would not get the 100%, Amanda. But in any case, I know, I feel bad making that comment about, oh, you didn't get 100% when you got 99% on every single one of your assessments. That 99% is still mind-blowing. So I don't want to take away anything from that by my comment about not getting 100%. As far as I'm concerned, that is 100%. That is a perfect result. So yes, it's very impressive. Okay, so Crispian explained. DYO, Dial Your Own, is a system where the driver nominates his expected time, loses if faster, and is held and compared to that time and the other racer. It is often within 1 or 2 hundredths. Wow, that would take some control. Said,
I love it when John talks about metric time, because that's when he starts sounding as sane as I am.
Yeah, that's when you know I've lost it. So... in order to do that, you'd have to know very accurately, well, okay, two things. You would have to have done many runs previously so that you've got a benchmark. You know what your car and you are capable of in terms of achieving a time on the track. So you have that as a reference point so that you can nominate, this is my goal time, and then be able to replicate that incredibly accurately with varying environmental conditions. For example, if your car is turbocharged and the air is cold, the car will make more power, which may make you go faster. It may cause more slippage. You know, there's so many factors involved, and reaction times and how many dozens of coffees you've had that morning. So many things. But yeah, if you can get within a couple of hundredths of a second of your nominated time, that is impressive. Okay, so Stephen said Pi 1 was just LED driving using DMX 512. Okay, so you were running DMX. Oh, Sasha is here as well. Welcome, Sasha. Okay, LED driving in your letterbox. Cool. Relware Tep is determined to just speak gobbledygook this stream. It's going to be the whole stream, isn't it, Pete? You can't help yourself. I'm almost catching up with the chat. I can see the bottom of the chat now. Lionel said the mental problem could be reduced by calling something other than hours, minutes, and seconds.
Time handler said, "Hello, people."
Metric time handler. Who is electric time handler? Oh, metric time handler. Hang on. Oh, it's Henrik. I can tell by looking at the icon and matching it up. So Henrik's changed his name to metric time handler. Yeah, but Lionel is right. We could call them Friezels, Bootsels, and Bimbits or something for hours, minutes, and seconds. Henrik said, I think it's way easier to understand the Testomatic than metric time. Oh, what I should do is make the Testomatic report all test results in metric time. Crispian says, did you know that a moment is actually 90 seconds? That seems long. If someone asked me, what is the technical definition of a moment, as in not moment of inertia, you know, from a physics, like a mechanical point of view, when we're talking about levers and things, but a moment in terms of time, I would have said a moment is somewhere in the vicinity of 15 to 20 seconds. 90 seconds seems too long for a moment. Ah, Sasha! Yes, finally got to catch a stream. Hello from Toronto, Canada. Welcome, Toronto. Andy says, time works best when you choose a base number that has a lot of divisors, e.g. 60 is a much better choice than 10. That's true. But in this case, yeah, so the thing is that if we switch to a metric time of 10, 100, 100, we would be increasing the hours and minutes and increasing the minutes and seconds and decreasing the hours. Paul asked, how did Andy's presentation go? And from the point of view of someone sitting in the audience, I can say it went very well. And hopefully it'll be up on YouTube before too long, because the talk was recorded. Okay, so for the very quick backstory, Andy did a talk at the AIML meetup in Melbourne just last week, and he was talking about language action models and how to use machine learning to control robots. So instead of just using like text-based interfaces or using them for speech, using them to determine the physical actions. So you can give it a goal, and then it controls the actions to achieve the goal. Essentially, predicting the next move. In a similar sort of way that large language models predict the next word, they start with a beginning and then they work out what comes next. When you are controlling a robot using a machine learning system, it is predicting the next move. So if its goal is to pick something up, the next move is moving towards that goal or moving further along. Yeah. Spicy chicken creamy pasta asked. Well, I think TTS is going to catch it up in a second, so I'll leave that. Okay. Wagon Load says, I measure time in RELs, RELs. In RE. Okay. I don't know what that's an acronym for. I probably should. Pete said, I'm make my secret project support metric time for the lulls. Yeah. Okay. It feels like I am really chasing the squirrels right now. Now, Pete has a link to Wikipedia. A moment of a unit of time. Did you moment unit? Moment unit. That link is incomplete. Unit, let's see, of time. I'm just going to see if I can find. Here we go. Does not have a. Nope, maybe it's not that. Moment, unit of time. Moment, unit. Ooh, okay. Here we go. Deep diving on a squirrel. What am I doing? That. Okay. A moment is a medieval unit of time. On a sundial covered 40 moments in a solar hour. Crispian was spot on. A twelfth of the period between sunrise and sunset. The length of a solar hour depended on the length of the day, which in turn varied with the season. Okay, so a medieval moment corresponded to 90 seconds. Wow. And on average, because varying with the length of the solar day. Whew. I did not know that. Medieval computists before the introduction of the mechanical clock and the base 60s system in the late 13th century. Okay, computists. I want to be a medieval computist. Next time someone asks me what I do, I'm going to say, I'm a computist. Ancient Venerable Bede, who describes the system as 1 solar hour equals 4 puncta equals 5 lunar puncta equals 10 minutes, 15 partes, 40 momenta. Alrighty. Well, now we know that a moment is 90 seconds. Crispian, I was wrong, you were right, I concede. It still feels like it still feels like 90 seconds for a moment is too long. Like if you're in conversation with someone and they want you to do something and you're just finishing something and you say just a moment, if they stand there for a minute and a half waiting for you to finish before you respond, is a long time. I'm tempted to just sit here silently for a moment, for 90 seconds, but no, it would feel so uncomfortable. Paul said, biological times, 200 milliseconds is the time where most people can distinguish between instantaneous events. Yeah, this is something that I've come across a number of times, and Wagon Loads, REL is Dalek time units. Okay, I did not get the Doctor Who reference. I've never really been a big Doctor Who person. Like, I've seen a bit of it, but and obviously I know who the Daleks are. I know who the Cybermen are. I love the clip of the, I can't remember what they were called. It was one of those, the statues that move when you're not looking at them. And yeah, that was a very, very cool concept. The whole idea of creating horror with no budget by just moving some statues around, that was writing genius. That was so clever. The Weeping Angels, yes, says Jack's Tech and Paul. Yes, yes, and the way he stopped them by getting them to face each other so that they were looking at each other and then they could never move for the rest of time. Unless some idiot came along and picked one up and moved it. And then it's all over. Poor Crispian says, "You are a medieval computist." I am. Paul Schultz says, 7 secs is the duration of now. If you are asked to reach for something on the other side of a room with your eyes closed, if you take less than 7 seconds, you can do it. Longer, your direction will wander. Yeah. Which reminds me, there was I think it was a Veritasium video like that I saw just during the week sometime. The whole thing about proving to a police officer. Hang on, I've just noticed that my microphone is really hot. Okay, hopefully that will not be hurting your ears quite as much. So a police officer says, "Close your eyes and walk a straight line." And Veritasium made the point that it's impossible. If you put people on a flat, featureless surface and say, "Close your eyes and walk in a straight line," they cannot do it. They will wander off. Their path will actually, to them it will feel like they're walking in a straight line, but without any external reference and without use of your eyes. Mark Rober, Tassie says, yes, maybe it was Mark Rober, it wasn't Veritasium. And if you plot their position, there is no way that you can walk a straight line. Andy says, when you're interrupted, it can take 15 plus minutes to get back into the zone. So someone can wait 90 seconds at least. Just be precise and ask, "Can you wait 90 seconds, please?" Yes. Interruptions and breaking flow state. That is a whole other thing. Yeah. Speaking of being interrupted and taking 15 plus minutes to get back into the zone, it is now 28 minutes. It is now a quarter of the way into this live stream and I'm still messing around with squirrels. Tassie Bob, going to Brisbane for a work Christmas party. So you're going to be Brizzy Bob. You can't be Tassie Bob anymore. You can't. QLD Bob doesn't work. Queensland Bob, it just doesn't have the same ring to it. You got to say Brizzy Bob. Going into a metal can to get free metal cans. Yes. Pete approves. So, who else have we got here? Mitchell is here. And Wagon Loads. And Imi has joined the chat. Okay, so now that Imi is here, we can get on with the important stuff. Not just talking about the definition of a moment. There was... where are we? That ding was... my sister's friend in a group chat about scuba diving trips, posting about diving stuff, making me want to go diving. Okay, I've got to ignore that. I'm going to take you on a little journey. And show you, where are we? IOMOD. Ding, says Pete. Yes. I should put my phone on Do Not Disturb. But stuff it. More interruptions. Okay. I shall allow the interruptions. No, I'm just in the process of opening this for anybody that's wondering what's going on, because I'm going to show you, I did another thing. I did a few things during the week. So actually I'll come back. I now have 3 different, oh yeah, so there's this one. In fact, I'll open all of these because we may well be needing to reference these designs and it'll help tell the story. And back to here and the 5593R, which one? Not there, not there. Did I move it into a subdirectory? I must have. I must have. Oh, and Fusion is doing something stupid. I feel like I'm perpetually complaining about Fusion, and of course the obvious answer that everybody gives is switch to keycard. But look at this. PCB out of date, changes may get discarded, update. What the hell does that mean? If there are changes in both 2D and 3D PCB, one set of changes must be discarded in order to sync. But, okay. This reminds me of some things that Andy was saying at the pub after his talk. Talking about distributed systems, there was someone else there, Deanne, from his AI plus ML plus robots group, and Deanne is interested in distributed systems. So Andy was talking about some of his vast experience with distributed systems, and distributed systems can break your brain. There are the rules that Andy was talking about. The 6 rules or things? The 6 things that if you... Anyway, this is the fundamental problem with a piece of software which runs locally on your computer but syncs with a cloud service. Once you have multiple instances of the desktop software on different machines syncing to that cloud service, you now have a distributed system and you have a concurrency problem. And Fusion is not handling it well. The problem is I edit stuff here at my desktop on the big screen, like the multiple screens and that sort of thing, because this is the convenient place to work. But I also edit things on my laptop, and I am very particular that I always save and allow it to sync, so it pushes any changes that I make back to the cloud service. So then when I go to the other device and I open the project, I should have the version that was most recently edited, no matter what device it was on. And just recently, like in the last week, after some update, Fusion has stopped handling that elegantly. I don't know what they've done, but they have broken their distributed system. So now what happens, probably like 50% of the time, when I open a project, it'll come up with this thing saying something like PCB out of date, changes may get discarded, update. So that's the help text, which is, if there are changes in both 2D and 3D PCB, one set of changes must be discarded in order to sync. And it's just got this thing that says update. You can either update or you can hide. What are the consequences? How are you even supposed to know if I click update, what does that do? Is it going to undo changes that I've done on the 2D?
3 years with Crispian. Nerd brag. Celebrating 3 years with Imogen.
Awesome, that was a double nerd brag. So Crispian and Imi have been together 3 years. Awesome. And you are spending your 3-year anniversary with me? That doesn't sound right. There's something wrong. You need to go and do something. Oh. Tassie says, and this is why I avoid cloud things. Yeah. So the first time I saw this message, which was maybe a week ago, I opened a project and I sat and thought about it for a moment and thought, what happens if I update? What happens if I just close this dialog? Which of those two things is worse? Am I going to be undoing changes in my local copy? Is this copy newer than the other one? Or is it older? If I ignore those changes, am I in a worse position? If I update, am I in a worse position? I don't know. And the software does not tell me. It doesn't give any indication of what the hell is going to happen if I click that update button. So I clicked the update button and it broke my local PCB. It undid some changes. What I ended up doing was like Control Zing to undo, going backwards and forwards to see what had happened, and it had undone some routing on the PCB. And I don't know why. It was, yeah. Anyway, rant. Pete, does this mean that it is your birthday today? Your birthday? Cool. Happy birthday, Pete, if that really is the case. You're younger than me. If you've been putting up with yourself for 55 years today, you're younger than me. Oh, Paul just said to Andy, thanks for the link. Where was that? Oh, yes. So, there we go. Andy linked the 8 fallacies of distributed computing. Yeah, that was what he was mentioning on Monday night or whenever it was. Yeah, Tuesday night? I can't remember. Whatever day of the week it was, I don't even know. I have a feeling it was Tuesday night. No, next month, but some kind of self-awareness kicks in when in the womb, says Peter. I don't think so. Also, there is a link further back that Andy posted for, which I think was to the slides for his talk. But when the actual video of the talk goes up, I will definitely mention that, and I will put a link to it in the chat, which won't be today. I don't know how long it takes for the talks to go up. Yeah, Andy says, Google Wave was a hot mess. However, the operational transfer tech ended up in Google Docs, e.g. maintaining consistency across multiple simultaneous updates. That is super impressive. The way Google Docs handles it is mind-boggling. The fact that it works, it's incredible. Yeah, okay, so PCB out of date. If there are changes in both 2D and 3D PCB, one set of changes must be discarded. Now, I do not... The 3D PCB that I generate out of this is... In fact, there isn't a 3D PCB. What's it talking about? Look at this. I've got the schematic. I've got the PCB layout. There's the project. And there is a mechanical drawing which has been derived from it. There is no 3D PCB, unless it's not in this folder. Let's see, is there a 3D? Oh, okay. This must be what it's referring to. So let's move this. Oh, I can't drag. No, there is no drag. Move into Testomatic. That one. Move. Okay. So maybe that is the one that it's talking about. Now, if I open this, is it going to say it's out of date? Yes. Component is out of date. Update. Click here to update all out of date references. All right, this is going to be a test. Let's see if I update the 3D PCB, which pulls it from the 2D layout from this one. Let's see if this warning goes away. So I am going to say component is out of date, update, yes. And this will update. Okay, so the 3D PCB is now updated. Now if I go back to the 2D PCB, let's see, the warning is gone. All right. That, ooh. I think I understand what's going on here, and I think I understand why they've made this change. But from a user's point of view, like from a discoverability point of view, this is horrible UI. It's okay. So what used to happen up until a week or so ago when Fusion updated is if you make changes to the 3D PCB, to the 2D PCB, I'm going to make a change here without saving it just to test this theory. I am going to drag the dimension of the board out. So I'm making the board one side a little bit wider on the right. Now the polygons haven't moved. It's just physically going to make the board wider without the copper changing. If I go to this is now reporting that the 3D thing is out of date, and it's saying PCB out of date, changes made. This warning has come back. And does this one have a warning? No, this one does not have a warning. But what it used to do was pop up a yellow banner that was just a warning that the 3D model was out of date. And the more I think about this, I actually prefer this behavior. What it's doing right now, I'm going to try to explain what I think is going on. What they have done is made the sync bidirectional. It used to be a single directional sync. So what would happen is if you edited the 2D PCB layout and then you went into the 3D model, it would say it's out of date and you could click the reference component to update. But if you changed the 3D model and then went into the PCB, it would warn you that the model was out of date, but you couldn't pull the changes back in. So I think what they have done is they've changed it so that it now has full bidirectional linking between the layout and the mechanical CAD, which is actually really cool. But that UI is terrible. Like the explanation of what it's doing and the fact that you can break things and not understand what's going on. So if I pull this, I'm just going to do an update link components. We should see the PCB get wider. There we go. So the PCB just got bigger. Oh, my space mouse is broken too, which is very annoying. But you can see the PCB has got a little wider. It's got 1 millimeter wider on the side. And this is now up to date. And back in here, this warning will have gone away because there is consistency between the 2D view and the 3D model. Okay, so now if I come into here, what can I do in the 3D model? What change could I make? Let's see if I can I change anything? Let's try taking that face. I don't even know if this is going to work. And, okay, so I can change new component, define board, link to 2D PCB. It's already linked to a 2D PCB. So if I make changes in here, it should then, back in here, say that this is out of date. And I can pull those mechanical CAD changes back into the PCB view. Okay. From a functionality point of view, that is actually pretty damn cool. From a user interface point of view, that's terrible. Like just that warning that pops up and doesn't explain what it is going to do. And if you click update, it's destructive because it's pulling it from the other thing. It hasn't explained. Okay. If they improved the user interface a bit and made it more self-explanatory, so now I can pull this and the side of the PCB is going to get narrower, then that is an incredibly powerful thing. But anyway, here I am ranting. Okay, I'm going to go back to the chat. Stephen said, Pete's face mouse is broken. Pete's broken. Yep. Okay. Oh, Don S is here. Good morning, Don. Don says, hi all, good to make the live stream after several busy weeks. Yeah, so how is life in NZ and what's been keeping you busy? If you're allowed to share. Pete is back to front. True. Wagon Load says, I had a difficult time doing true-false tests because I could always think of another option, like, is the sky blue? Yes. Okay, Wagon Loads. I think you are, by saying that, you are revealing things about your brain. Yes. What you're exhibiting, I'm being careful what I say here because I am not in any way qualified to make any assessments of how anyone else's brain works or how my own brain works. But just in terms of functionality, this is the classic symptom of being in an assessment, reading into the question. You know what they mean in the way they've asked the question, and you know what answer they are looking for, and if you could answer it that way and they would mark you as correct, but you know that it is not necessarily pedantically correct. David said, okay, just say it, he's a nutcase, a Fruit Loop, a squirrel, like all of us. Yep. Oh, Don said, sold a house, bought a house, and have 2 new job contracts to choose from. Wow. That has been a busy time. Yes. Andy says, binary, true, false isn't sufficient. We should always have ternary, true, false, and don't know. Yeah. If we're talking about, yeah, I've had this a number of times. Like I've come across this. I know that I've come across this in scuba assessments where you have to do, in fact, I came across this quite recently, maybe a year ago, when I was doing, it was part of a dive course I was doing to add deep dive certification. And there was a particular question, I can't remember what the question was, but there was a particular question where you had to answer it in a certain way that actually was not technically correct in order to pass, like in order to be judged as correct on that question. And the instructor that I was doing this, this class with realized this as well. The good thing is that the instructor was a very smart guy. He understood what was going on. So, and this was like it was an oral assessment thing. And he was saying, okay, so question is, you know, if this happens in these circumstances, what do you do? And there were like a number of options of things you could do. And I said, well, I know that the answer I'm supposed to give is this one, but actually this other one is technically more correct. And he said, yeah, you're right. We'll take that as a correct answer. Anyway, so Pete said, in case you missed it, Proxmox now supports, albeit in a preview state now, not fully supported, OCI images on the host metal. Okay, cool. Useful for people who use Proxmox. Yeah, I should see if I can find the, I won't do it right now. Let's see if I can find the assessment questions for the deep diving certification, and the one that, it was something to do with nitrogen outgassing, I think. Yeah. So, okay, so back to the point. How much time has gone by? So, yes, okay, I'm going to close that without saving. That's the 3D model of the... Or maybe I should just have the 3D models open. Okay, here's my I did a thing. So, my original plan, here we go. Let's come back to here, Testomatic. My original plan was to do a pluggable I/O module for the Testomatic chassis based around the AD5593R, and for that to be, and this is still my plan, I've just taken a side quest, and for that to be the like the general purpose module, because it can do digital in, digital out, easy, at either 5.5 or 3.3 volts. It can do analog in, 12-bit, and yeah, 12-bit analog in, which is fine for most things. You just want to measure a signal between 0 and 3.3 or 0 and 5 volts or whatever. That's fine. And it can do true DAC 12-bit output. So not just PWM output, but it's got an actual DAC in it. So you can set to an arbitrary voltage and get a nice smooth constant voltage. You're not getting the square wave PWM kind of simulation of analog out, which is what you get a lot of the time. So if you want to set a reference voltage for your device under test, using a DAC, you can set a nice smooth voltage and it works nicely. So the 5593R is really good as a general purpose I/O expander because it covers all four of those use cases of digital in, digital out, analog in, analog out. And it does it in a clean fashion. It's not the highest resolution or accuracy ADC in the world. It's not the greatest DAC in the world. And it's not the fastest thing because we're talking to it over I2C, but still, it covers all of those things. So it's like a really good rock solid foundation, and if you put this module in, you can cover all of those common use cases. So, that is the first one that I made, which is this one. So it is, in fact, what I should do, I'm just wondering if I should get the chat up on screen. No, I won't for now. I'll use all the screen real estate for this. So this is the AD 5593R version of the I/O module, and you can see that it uses what have we got? So we've got I2C. Let's what am I doing here? Let's look for I'm thrown because I'm looking at this on such a small screen. I can't even see all the tools, the toolbars and things. So yeah, everything is small. There we go. There's the tab I'm expecting to see. Let's have a look at T-Place. No, not that. Not that. Oi. Yeah, okay. Where are we? Silk screen, T-Place. I'll get rid of names and values. Do not care about that. Get rid of B-Place. Okay. So we are looking at the module upside down because it is designed to be assembled. Hang on, I've got a cough. Okay, hopefully that's a little bit better. I'll take the opportunity, take a drink as well. All right, now it is designed to be assembled with the parts on this side and then turned over so that when it's mounted in its socket, all the parts are underneath and you've got a smooth surface on the top. And I deliberately did that because I wanted the top of the PCB to be totally flat so I could cover it with labels and things. And the parts can all be underneath where they don't get in the way. So the design is backwards. The connector that you can see on the right, it's basically a mirror image, flipped left-right. So the connector you can see on the right is actually the left-hand connector and vice versa. So I designed the whole thing inverted in my head, which started off being a little confusing, but then it just makes sense. So this is the first module, and I have a bunch of them. Where are they? Where are they? I might, here. I have a bunch of them in the bag, assembled. We have spent way too long on stream messing around with those, and with the Python driver that I've been writing for those, which is working apart from a scaling issue on analog. The VREF setting needs to be, yeah, there is an issue with transferring some settings to a register in a particular order. I still need to resolve that. So what's happening at the moment is that the VREF scaling is always set to 1x and the VREF is set to 2.5 volts, which means that you can never drive more than 2.5 volts on analog in, and you can never read more than 2.5 on analog, on analog out, and you can never read more than 2.5 on analog in. So I've got to fix that VRF scaling issue in the driver. So, Wagon Load says, I tried making a DAC using 10-turn pots for each step. Ooh, that sounds like an interesting exercise, Wagon Loads. Yeah, so this, I still believe, is going to be probably the fundamental I/O module that I use. The main downside is the cost, because this chip, the AD, is, how much is it? It's like $15 or $17 or something for one chip. So the actual modules end up being very expensive. That's the price you pay basically for all the flexibility of what it can do with the combination of DAC and everything all in with 8 channels. So it's, I'm pretty sure, is it a multiplex DAC? I can't remember. I think it might be internally a single DAC. Yeah, well, how does it even maintain? I don't know. Anyway, that's something for future me to figure out. So this is the Serial Wombat version of the IOMOD. Let's go to... if I push, so it's saying this is out of date. If I push, what happens? Okay, so then I can pull from here. Do I want to discard those changes and update the design? Yes. Yeah, I'm still slightly confused by the workflow weirdness that's going on here. So SW, okay, so let's get rid of that. I want to see more tabs. More tabs! So this one I will also push to 3D. And this one, not that one, not that one. That one I did just push to 3D. Where are all the other tabs? I want the SW8. Push that one to 3D. Oh, I already had it. Okay, which ones have I got? So the 23008, I've got the SW8B. I have not pushed this one. Okay. So let's push this one to 3D. Okay, now we've got the 3D models. Should the label be AD5593R? Yes, Paul. I was just looking at the wrong one. Okay, so we have this one, which is the AD5593R. I am so annoyed that my Space Mouse is not working right now. Each time macOS does an update, it breaks my Space Mouse, and then I've got to figure out how to make it work again. I'm going to, what if I try running the 3D connection helper? Where is it? Support feedback videos? No. Can I? This is annoying me so much. I'm actually going to do something about this. Where is... I'm just opening a window, downloads. I should have... What I should do is stick the installer for it somewhere. 3D... 3D... What about connects? No, I must have deleted the driver. Space mouse installer. Go. Drivers. Okay. This time I need to keep the... come on. Yeah. Explore, space mouse, come on. Where's the driver? Download, software. Here we go. Okay. 3D connection, download. Download for Mac OS. Okay. If this requires a restart, I am not going to do it because that is too much of a pain. Continue, agree, yes, install for all users, yes. Install. Okay. Installing a system extension, yes. Do it. It's worth getting this working because it'll just make it easier to show you things, because it's the 3D stuff that I want to show you. It'll make it a whole lot more. Would like to access files in a removable volume. Yes, allow. Do it. Just install the driver. Oh, come on. This is the 4th time I have typed my password to install the driver. Installation complete. Please restart your Mac. No, screw that. I am not doing that. Okay, I'm just going to live with the fact that my Space Mouse is currently broken. So I can, when I twist it, it zooms, but pull and push, which is basically the same as like a scroll wheel on a mouse. So rotating the Space Mouse is like a scroll wheel. So this is the scroll wheel on my trackball, and this is the Space Mouse rotating. But I can't do the 9 degree of freedom thing that the Space Mouse normally supports. Okay, I'm just going to have to live with that until after the stream. Alright, so this is the 5593 version. This one is the Serial Wombat version, which is using the CH3V00 whatever, you know, the 10-cent micro. So that is, yeah, that is that module. Serial Wombat, and that is it this one? This one, yes. I have those. So I've ordered panels and parts and everything for all of these. So this, in fact, I should get them out, stick them. I will move that out of the way before I change cameras, because that is a secret thing that I'm about to reveal. Put that under the camera. What else? Where's the other one? This one. This one. I've got to find one with a header. Where's the one with the header? There. Ah! Dropped it on the carpet. It's dead now. It is no longer ESD safe. Okay. What am I trying to do? Overhead camera, that's right. This one. Okay. Now I'm breaking everything. Where's the camera? There. All right. I zoomed the camera way in because I knew I would be showing you small stuff. Oh, they're all upside down. So these are, this one is the new, this is the reveal that you haven't seen before. So this is the IO module with the 805593R on it. And this is an I2C IO expander. So it's got all the parts on the bottom. And That means the top is all flat. There's nothing on this side of the PCB so that it can have labels and everything on it. This one, oh, hang on, 8055. Those two are the same. What am I doing? So there's that one. Where's the Serial Wombat one? It was right here. I had it. I know I had it. Serial WOM. Yeah, that one's a Serial WOM. Okay, so then I need... Oh, it's that one. I see. I am really not doing well today. I'm even more disorganized than usual. Oh, the other one, I know where it is. It's in the... It is in the Testomatic chassis. I'm going to try to pull it out so I can show you. Yeah, getting these modules in and out is not super practical. You need little fingers or a hook or something. Okay, so 805593R version, Serial Wombat version. So this is the version with the 10-cent microcontroller, which you can see right there, pointing with some solder paste. And the new one that I just did is this one. It's an MCP 23008 version. So I assembled this during the week. It is, once again, parts on the bottom. So it has the MCP 23008 on there, which is the little baby version of the MCP 23017 that we've used on so many projects. But this one is physically smaller and it only has one I/O port, not two. So it's 8 bits. It's got 8 I/O pins. There are level shifters here for I2C. There are a couple of diodes on here. Even zoomed in this far, you can barely see it. So there are a couple of diodes here because it's got open collector connections for interrupt and whatever the other thing was. What was the other signal? Reset and interrupt. Yep. Yeah, so all of this came about as a result of frustration with the driver situation and with software. So this one is the one that I think is going to become the general universal one. This one has the potential to be a general universal one, but certainly a lot cheaper because it's got the 10-cent micro on it. I don't actually know if they're 10 cents, I can't remember, but they're cheap anyway, they're really cheap. So it's got they're just referred to as the 10-cent micro. So these boards are super cheap to make and they can do a whole lot of things. But they need firmware loaded onto the micro to turn them into an I/O expander. So that one is, okay, I'm going to come back to this. Let's bookmark that. I hate to use the term, put a pin in it. Can't stand that. So anyway, we will come back to that. We need firmware on this to make it useful. This is Jonathan Broadwell's project, as in the firmware. This board is designed to run Jonathan's firmware. The micro that is on here can be flashed with his firmware to turn it into an I/O expander. So my plan with this is to run Jonathan Broadwell's Serial Wombat firmware on that micro, and then that will be an I/O expander. Okay, now this one is one that I designed in a moment of frustration a couple of weeks ago because the reason being, this one I've had trouble with getting the Python driver working. This one I need to get firmware onto it and I didn't have a programmer to load it with. And I had one of those, you know, have a temper tantrum and throw all your toys out of the cot moment. And I thought, screw it, I'm going to design an I/O module that uses a chip that I am very familiar with, that I know is not a problem for drivers, and I am 100% confident that it is just going to work. It's not going to do everything I want, but it's going to give me at least a baseline, a simple starting point so that I can work up from there. So one day I just laid out this board, sent it off for production, ordered the little QFN versions of the IO expander chip, and then I assembled a panel of them. So I assembled like 32 or however many was on a panel of these. So I now have several dozen of each of these modules. Like, yeah.
Your moment of frustration, 90 seconds is pretty fast to design an entire layout.
Yeah, you're right. Yeah, it might have taken me several moments to lay out this board, but it actually was not long. It was a case of a bit of language and, you know, screw this, I'm doing another one. Because I hit a wall on the path that I was taking, and I jumped and said, okay, I'm going to take this path, solve it this way. So yeah, it didn't take very long. I just laid out this board and sent it off for fab, and it came back and I assembled it and it works. There's the spoiler is I plugged this in and it just worked. No problem, 100%. I can address all of the I/O pins. I can drive them as digital outputs. I can read them as digital inputs. The level shifting works, so I can do 3.3 volt I/O, I can do 5 volt I/O. This module with the 23008 actually does exactly what I want. First off, V1.0, the board works perfectly. And it was done in a moment of frustration. So, in moments of frustration. Yeah, all right, and these, you can see. This is, oops. Because this is panelized, I just ran it through the pick and place machine and assembled a panel. So I didn't bother assembling just one to validate the design. I assembled a panel and ended up with 32 or however many it is. Whatever the number is. So I've got a bunch of them. And I have that same number. So I have the same quantity of each of these three versions of the I/O module. And now this brings us back to, no, okay, before I get to the other thing, I'm going to show you something else that I have been doing. So this is going to show you how petty my mind is and how easily distracted I am by shiny things, because I designed these modules to be upside down in order to have the flat surface on the top that I mentioned earlier, so I could put labels on them. So I've got numbers down the side here for the I/O pins, markings for ground and ground, for VBus and VIO for the two power rails. There are markings on here for the digital interface that goes to the microcontroller. The way this is laid out, it is a bifurcated design. Everything on the left side is internal. That goes to the microcontroller. Everything on the right side is external, and and goes to the device under test. So you can have two different voltage, like two different power domains. You could have 3.3 volts to your micro and 5 volts to your device under test, or 3.3 and 3.3 and whatever. So it's a split design, and all of these modules do the same thing. They've all got that dual design. Now, my original idea had been that I would order each of these modules in a different PCB color, and I would standardize on it. So for example, the 805593R would be blue, and the Serial Wombat would be green, or whatever. And then when you're looking at the chassis, like if you're looking at a Testomatic, you can glance at it and you know what modules you've got installed. And now, of course, they can be checked by the test runner script. So if you have your chassis set up incorrectly and you don't have the correct modules plugged in, then the test runner could say, there is no device at, say it's expecting an MCP23008 test module or IO module, and it checks and there is no device at hex 20, then it knows, but there is one at hex 60, then it knows that it's got the wrong module stuck in that socket. It's got a serial wombat instead of a 23008 or whatever. So it's not really dangerous, but I like the idea of each of the modules being a different color. But when I went to order PCBs, blue adds a little bit to the price. Green is the cheapest. Anything else dramatically increases the PCB cost. And I was trying to keep the cost down. And the thing is that even so, I wanted more colors. So this is how I nerd sniped myself. No, nerd sniped is the wrong term in this context because it wasn't done by someone else. I did it to myself. This is a total self-own. I tripped over my own foot. I wanted to have a way of visually distinguishing these boards from each other and make the labels really super clear. So I then started thinking, how about I just have them all fabricated in the same color for minimal cost. So do them all in green or blue, whatever is just the default cheapest, and then put a sticker on it. And that way I can make the sticker whatever color I like. And I've got, where are we? Yeah, I've got, I think it was, it's 8mm in between the solder pins. So the connectors are sticking up, like the solder joints for the connectors are sticking up. And it's these modules are 12mm wide, and so they're all metric. It's 2mm pitch pin headers, and 8mm plus a little bit in between the pins. So I thought what I could do is make stickers that are 8mm by 20mm, and then I could just put a sticker on each one, and I could have one blue, one red, one green, one black, one white, whatever, and you could easily see what they are. And by printing stickers, which you can do with a much higher resolution than silkscreen, I'd be able to get sharp labels and everything, and it would look really nice. So I'm just going to slide back to my computer for a little bit and show you what I did. I've got to get into Affinity. Affinity. Okay. Speaking of which, Affinity did a new... oops, no, I want that. No, I want... why did that happen? Where did Affinity go? No, not WhatsApp. Where did Affinity go? Not that. Oh yes, this is something I'm going to mention as well. What on earth happened to Affinity? Hang on, I'm going to switch to that camera so that I can now, jump around screens and things here without worrying about what it is that I am exposing. Affinity, show all windows. There it is. What? Okay, I'm going to quit out of Affinity and try to bring it back because it is, yeah. Max Window Manager just did something bizarre. It threw the window out into no man's land where it could not be retrieved. I could bring it back on like the window expose thing, but then not have it reappear on the screen. Okay, so I started playing around with ideas. For stickers. So these are 8mm by 20mm. And my general idea was, what I could do is, yeah, and I know that red on green is really hard on the eyes. I was just playing around with different color schemes. So what I could do is go to somewhere like Officeworks that does custom sticker printing, and there are plenty of places around that'll do custom stickers, and use standard size stickers. Like say you get a sticker that is 50 millimeters by 100 millimeters as like just a default size. I could lay out a bunch of these to fit within that with some trim marks and things, and then just have stickers made, and then I could cut them up so that I would end up with the 8 by 20 millimeter sticker size. That would be the most economical way of doing it. So these first versions that I did were based around the idea of, just turn on guides. Yeah, no, you don't need the guides. Were based around the idea of putting the sticker on the face of the PCB so that it would fit between the pin headers, because we've got the solder joints and the pins sticking up from the pin headers that come through the PCB. So the actual dimensions of this, actually, yes, I'll turn the guides back on. So this pair of guides, for example, is 8 millimeters apart. So that is the width of that sticker, and it's 20 millimeters long. And then I had an idea. What about if, okay, where's Fusion? Where is Fusion? Come back to here. What if I 3D printed a little cap that goes on top, so it would cover up the top of the module, including over the pins, and turn it into a block and give a flat surface that is the entire size of the PCB. And come on. This was the result. IOMOD cap. The idea is that it's a flat cap that could be glued onto the top of the PCB on the I/O module. It's got clearances underneath. The two long slots are clearances for the pins sticking through, and then this center section is basically just glue channel. So what I could do is put a dab of glue on the top of the PCB, and then just stick the end cap on, and the glue will squish and run through those channels, and that will also, so it'll mean that the glue can spread without going, like without squishing out the sides and being ugly. So I'll end up with the IOMOD having this little cap on it, so that it'll be like a flat surface. And I experimented with printing. So this is one printed in orange. This was a previous one. So this was the one, one that I printed first before I added the little glue channels in the middle. And then this is the version with the glue channels. And I thought that what I could do is print these in different colors, because I could just get filament that matches. So I could get blue filament to go on this, use orange filament for a different one. It just sits onto the top of the PCB like that. And when glued in place, it gives the IOMOD a totally flat top, so it turns it into a block and makes it much neater. And then the sticker could go on that. So that brings us back to here and here. So then what I did was I expanded the width. So I went from 8 millimeters width to 12 millimeters width, which is the actual width of the module. So it means that I can increase the font size, I can make the labels a lot clearer on the pins, and overall I think it just looks much nicer. So that was also what I was doing was experimenting with both SPI and I2C labeling. So on this one you can see that there's no SDA and SCL, which are the pins that would normally be here, but it has the SPI pins labeled because they are in use on the S or the SPI version of that particular thing. Jack said, why bother with the label? You can just print into the 3D print. Yeah, but the resolution is terrible. It's actually kind of hard to convey how small these things are. Get yourself a ruler and draw a rectangle that is 12 millimeters by, actually no, draw a rectangle that is 8 millimeters by 20 millimeters. That is the printable area on the top of the PCB. That's that area there. This text is so small that trying to print it, like trying to 3D print this, would just not be feasible. It really needs the resolution of real 2D printing. High resolution ink on plastic or whatever the sticker process is, however they do it. So then I played around with a couple of different ideas for, once again, for color schemes and things for 12 by whatevers. And then I thought, what I could do. I was worried about adhesion, because if it's got a plastic cover on top of it, then, and I put a sticker on it, you know what it's like when you try to put stickers on plastic, often they just won't work very well, or they may stick, for a while, and then a month later, the labels are coming off because the plastic just prevents it from adhering properly. And then I thought of, you know, those servo testers that you can get. I've got a few of them around here. I won't bother pulling one out. But you know those servo testers you can get. In fact, I'll see if I can find a photo of one. Servo tester. Here we go. That the enclosure for it, this type here, images, is a printed piece of cardboard just wrapped around it and glued in place. These things are like a brilliant example of absolutely minimalist packaging at at almost no cost. So what they do is they have the PCB that you can see there. I'll see if I can zoom. Can I zoom more than that? No, I can't. Okay, so there is the PCB. There is a piece of ESD safe foam that is stuck to the bottom of the PCB, and that gives it like a nice flat surface because there are solder joints and things on the bottom of the PCB. And then this blue part is, I think on some of them they may be plastic. It's just like printed plastic with folds in it. So they just bend it around the PCB and stick it onto itself. This is, and they're kind of spongy and soft because it's not a proper box. It's just it's a strip of plastic that has been wrapped around. And the PCB is held inside it by the pot that comes up. So the knob sticks up through a hole in the plastic, and then they stick the knob onto it. So the shaft for the pot just sticks through the plastic, and that's what stops it falling out. It is so minimalist, it's incredible, and it must cost them like 2 cents per thing to produce the enclosure rather than putting it inside a box. So if you look at other servo testers, oh, this one looks fancy. This one is inside an aluminium enclosure, and it looks like it's probably actually the exact same PCB internally. It's just inside a box. And and also you can see here they've printed, they've actually used the opportunity, because you can print on that plastic, to put the instructions directly on it. So you just turn it over and the instructions are printed on the bottom of it. When I first saw this many years ago, when I first saw one of these servo testers, I was very impressed by the ingenuity of how they could do something that is so cheap and yet functional. Yeah, it's very impressive. So I basically stole that idea, and I'll come back to this. This is cool. This is cool. So what I did was I stole the idea and I added tabs. Now if we look at, it doesn't matter which one, the 805593R, what we've got is the rectangle that you can see here, which is 12 millimeters by 20 millimeters. That fits onto the front face of the plastic cap for the IOMOD, and then the plastic cap is I think 2 millimeters thick, and then the PCB is 1.2 millimeters thick, or is the cap more than 2? I can't remember. But in any case, by the time you wrap around the end and then go down the end and then wrap under, it needs about 4 millimeters. So from that edge there to that edge there is about 4 millimeters, give or take. Well, no, not give or take. It is precisely 4 millimeters on the label. It is give or take in the reality of the actual physical thing because of, just tolerances of stuff. But making the label 4 millimeters fits. So the idea with this, oh, I haven't changed those colors. Okay, so which is this one? It's that one. I am going to, where are they? Lines. That line needs to be yellow, and that line needs to be yellow as well. So those are the inversion bars on the reset and interrupt lines. Yeah, so the idea here is this sticks on the front of the module, and then the two tabs just wrap around and stick to each other. So the idea is that you would put the label onto the top of the module. This bottom tab you would just wrap around and it would stick onto the components like the microcontroller, etc., on the bottom of the PCB. And then the other one would wrap over the top of the module and it would stick onto the other tab, so that this would stick onto this. And it just envelops the whole module, and that way it won't ever fall off. The label is a complete wraparound. So, Grant says you can probably laser or inkjet print those, then laminate them, avoiding office work. It's not sure about the folds after laminating. Yeah, so here we go. This is one printed test. Oh, this was an early printed test. That's right. This is not the most recent. I threw that out. But then this one is a more recent printed test. And yeah, but the issue is making them self-adhesive as well.
At Tinker001 said, now to design 3D printer label application device.
That is a very big squirrel to throw at me. Now I'm using, this particular cap is orange, and I'm using this on camera now because it's easy to see. But what I also did was I batched them up, and these ones, these black ones, these are printed in ESD safe PETG. So this is a very expensive filament which is specifically designed for ESD safety, and it's like 160 bucks a kilo or something for this. So it's expensive filament. I don't want to use it in vast quantities, but it's, yeah, for this sort of thing it's perfect, but it only comes in black. I can't, because of the carbon impregnation or whatever it is that they do to make it ESD safe. So the idea is that instead of relying on the cap for color, it means that all of the caps can just be black. They can just be the same color. And then, so if I put the cap on this, so that fits on there, turns it into a little block, and then it is the label that provides the color. So the label would go on there. And this is just printed on paper at the moment, but if this was actually if this was adhesive, if it was a sticker, that would stick on the top like that, and then fold around the end and stick on there. Yeah, the depth of field of focus is not great on this overhead camera. I'm zoomed right in as far as I can go. And then that one would fold over and stick onto the other thing. So they would be, that adhesive would work very well because it would be the sticker sticking onto itself. And then you end up with a nicely labeled little thing with all the colors that I could want, because it can be printed in full color. So I've got ground markings down here, I've got power markings, all of the IO pins labeled nicely. And if there are multiple modules in the tester chassis, because they're all dramatically different colors, it's really obvious what they are. So you just glance at that and go, oh yeah, that's an 805593R module because it's yellow. And then another one would be black or white or green or blue or whatever. So yeah, I think that is actually kind of cool. So this was a side quest that I was chasing. And I think it would work out nicely. So, doing them with stickers. Yes, doing them with stickers, I think, is the plan.
Laser print a tiny little Steve onto each label.
Ah, yes, yes, yes. I was going to do that. So, what I need to do though is recreate Steve inside Affinity, and or bring it in as a bitmap or something. So the way I have it on PCBs at the moment, if I go to Fusion, yeah, so the way Steve exists at the moment on these PCBs is that I traced it, Testomatic, I traced it with actual lines, like Bezier sort of curves, inside Fusion. And I need a version, Donna says vector-based, yeah. Testomatic. Oh, Simon says, I've used a good old glue stick to put labels on PCBs in the past. They never come off. Oh, really? That's cool. Yeah. Who was it? I think it was Grant who earlier made a comment about laminating or whatever, the paper. Yeah, I've been wondering about, yeah, so the Steve that is here is, yeah, so these are curves. I painstakingly traced this out with individual lines and then setting, like this one for example, if we look at this line, you can see that it has a curve of 8.018 etc. degrees, because these are like Bezier spline type things, and I sat here and drew them and moved the points and everything to get the shape correct. So I need to do that same sort of thing, or have a version somewhere around. I think there is a version that I could bring into Affinity and stick Steve on here. Yes. Oh, Jacksec said, just glue the paper to the underside. No need to spend money on extra sticker paper. The problem is that I want the top, as it wraps around, it doesn't want to stay perfectly square. The bit on the top wants to sort of come away from the plastic. So I think adhering it to the top is going to be important. Screenshot the image, trace in Inkscape, says Paul. Yeah, except I do it in Affinity. This is the equivalent of Inkscape. Essentially, it's like I'm in vector mode in Affinity right now. So this is the equivalent of Illustrator or Inkscape. Yeah, so I pull it into here. This, for reference, this piece of software that I've got open right now, Affinity, is the equivalent of Photoshop, Illustrator, and a couple of other things, all combined into one, into a single unified package. So yeah, you can be in pixel mode or vector mode, and so pixel mode is as if you're in Photoshop, vector mode is as if you're in Illustrator. Yeah, Jacksec said glue stick will work for that. Yes. And Paul says, why not put the double layer sticker on the top? Easier to assemble. It would be easier to assemble. I have a feeling it might be harder to get the alignment correct though, because it's the alignment of the bit on top that has to be precise to the rectangle of the top cap, and then the tabs can just fold under and they can follow the deformations of the components and things, because the bottom of the PCB actually has parts all over it. So the bottom labels will sort of go over those and not be directly on the PCB itself. If I had it the other way around, where it went from under the PCB and then the two tabs wrapped up and one went down and then the other one went on top of it, I would need to be, it's the one that ends up on top, which is the last piece you put down, which has to be positioned precisely. So I don't think I'd be able to achieve that as well as doing it the other way around. I think the piece that has to be positioned precisely should be the first piece that gets put down, and then the other bits conform to the shape of the parts, rather than conforming to the shape of the parts, fold one tab down, and then fold the last tab down, which has to be in a precise position. Crispian says, Jono doing the Macarena. Yeah. Oh, Mr. Fix-It! Hey, finally made it. Been busy surviving light deficit disorder. Winter is coming fast in Northwest USA. Mr. Fix-It, it is so good to see you in the chat. Yeah. Oh, and as Mitchell pointed out, and it's now free. Yeah, Affinity, it's free. Like, this is pro-grade design software that is like a serious replacement for Photoshop and yeah, and that sort of thing. And it is 100% free. You just download it, install it, and run it. It is not open source. This is actually commercial software, but it is free. I think the way their business model works is that there is it's like a prosumer version. There are limitations within this, and this does worry me a little bit. They have gone on the AI bandwagon, and the pro version that you do pay a license for, you get you get AI integration into the tool, and I don't have that, so because I'm just using the free version. But so the reason that worries me is that I don't have the faith that their business model is going to be sustainable. If their bet is that they want creative professionals to pay them the license fee to use the version with AI in it, and then for normal people like me to just use the free version with no AI, I'm not sure that creative professionals are necessarily going to pay that fee. I think they'll just use the free version because it is awesome. It does all the Photoshop-y and Illustrator-y things. So I have a feeling that they have fallen for the hype train that
Canva bought them. Basically an entry-level drug for Canva and Canva integration. They're just trying to compete with Adobe.
Okay, that's what it is. All right. So Canva bought them and made this free. So my worry was that they had drunk the AI drug and thought that if they just add AI to a product, now everybody's going to pay for it. So anyway, hopefully it's all good. Tima says, a colleague's husband works at Canva. I'll ask about the strategy. Yeah. I seriously doubt that, you would be able to get information that you would be able to share publicly about their business strategy. If that's the sort of thing that is really interesting to me. I love learning about things like business models and how business strategies and revenue structures work. But that is exactly the sort of thing that businesses typically do not share. They want to keep all of that stuff to themselves. So yeah, it can be hard to find out sometimes, or hard to find out the reasoning behind things like pricing structures and why things are done in certain ways from a business perspective. But if you can find out, I would love to know. Tima, that would be really cool. We got Stephen 4479, Don S, Johnny Bergdahl is here. Hey, Johnny. John Whips is here. Andrew Tima. Okay. The cast note was catching up on the names in all of the things. David Crisp said it's free. What's the catch? Yeah. Hence the discussion about business models. But Mr. Fixit, yes, back to Mr. Fixit. It is so cool seeing you in the chat again, and I hope that things are going well for you. I know you've had a few things to deal with over the last year or two in particular. I hope life is smooth for you, Mr. Fixit. Okay, so it looks like, oh, blocked. Bad word detected. I wonder why. Okay, I'm just going to read this. Mitchell said, I actually pay for Canva Pro. It has a bunch of features that make it worth it, and now Affinity integrates, makes it like the Adobe stack. Canva was the replacement for Adobe. Simple though. Okay, for some reason, TTS wouldn't say that because there was a bad word. Maybe the bad word was Adobe? Could be. Yeah, right, okay, so this is one of the many squirrels that I've been chasing. So I was playing around with ideas for different labels for different modules. It's very quick to mess around with in here. Like I can duplicate a label, change a few colors in a few layers, and change some text, and now I've got one that looks a little bit different. So I was experimenting, for example, well, this is the SPI version, so I would need to change this. What labels do I need? CS, MOSI, MISO, SCK. Okay, so in here, where is that one? MCP 23008. I want to, yeah, the left labels are wrong. VIO, so down here, what was it? CS, oops, MOSI, MISO, SCK, yeah, that was it, I think. I'm just deleting until I get ground coming back up. There we go. So, oh, that's right. I need to get rid of, I need to get rid of SDA, replace that with the space, and SCL, replace that with the space. I actually don't even know about the int and RST pins. I'd have to check the schematic to see if I've even routed those signals out. So there we've got the, this doesn't physically exist yet. There are no SPI IOMODs right now. I actually want to do one because I have routed SPI to the footprint for the modules on the Testomatic. I just don't have any modules that can plug into it so that I can use them. And so there's the MCP 23008. This is the one that I built, which I just showed you, which is I2C. And there is the MCP 23S08, which is functionally the same chip, but it has an SPI interface. And I'm kind of tempted to, I haven't even laid out the board for this one. It wouldn't take long. But what I'm tempted to lay out the board and fabricate the SPI version so that, just to validate it, I want to have an SPI module that I can plug in and see that it's going to work. So yeah, where are we up to? Oh, Anymule says if the colors are just there so you can differentiate models, why not just get different colored PCBs done when you make them? Because of the, well, two things. Firstly, the cost. Anymules, it's possible that you weren't here earlier when I started this whole thing, because I found when I went to, in fact, let's do this. Let's do this. I'm going to just try something. I'm not even sure if I'm going to be able to, if I'm going to be able to do this without uploading. I think I can. I'm pretty sure that I can, my account order history. Let's have a look at changing colors. So the two things. Firstly, it makes the price way more. Where? Not that one, not that one. Where's? Was it with that batch? Was it with that batch? Wasn't that one. Oh yeah, there. Okay, this will do. Product details. So this was an MCP 23008. This is the most recent one. Let's go to reorder. Why am I... There is something wrong with my brain. There is seriously something wrong with my brain. Okay, reorder. Ooh. 10 minutes to end. Also, have you measured the filament ohm? Says spicy chicken creamy pasta. I have tried, and thank you for the super chat. I'm going to reorder that one. Thank you for the super chat. Spicy chicken creamy pasta. Yeah, so the question was, have I measured the filament ohm? I have, and it is not conductive. Okay, so there is a whole side thing I could get into here about ESD safe versus ESD dissipative. And okay, my understanding is that this filament is ESD safe, but it is not ESD dissipative. So for, I just said I wasn't going to get into this side quest. All right, the difference is for something to be ESD dissipative, like the the workbench surfaces and things, like the surface on my workbench. It's like a rubberized top finish with a carbon impregnated layer underneath, and it will actually conduct, but the level of conduction is high enough that it won't cause short circuits when you put live PCBs and things down on it. Another one! $2 of free Google money! Thank you, Peter. Cool. So, thank you, Peter. So, you can't work on a conductive surface like a metal table. If you put live power down on it, it's going to short circuit, stuff goes bang, it's all bad. You also do not want to work on a surface that can allow static to build up on it. So you need a little bit of conductance. And the accepted range, I believe, is 10 to the power of 6, somewhere between 10 to the power of 6 ohms and 10 to the power of 9. Like that's the range which is considered to be static dissipative safe. So and what that will mean is that if there is an electrostatic charge applied to it, it will bleed away through that material because it is dissipative. And another one from Spicy Chicken Creamy Pasta. They're all coming right at the end of the stream. Is this... Okay, so does this mean that I need to eat a hot dog for lunch? That was what was in Spicy Chicken Creamy Pasta's chat. Hang on, I'm going to put this up. You can't see the chat. Okay, so... Yeah. If you have a static dissipative surface, it will allow the ESD to discharge through it. If you have a static safe material, it won't allow a charge to be built up in the first place. And that's what this filament is. So it is, I've actually tried measuring. I've stuck a multimeter on the filament and the resistance is high enough that the multimeter does not register anything meaningful. It's like, it's way up in the many, many mega ohms resistance. So it's not really static dissipative, but if it's like if it's rubbed against something, it will not build up a static charge. So the filament that I've got is ESD safe, but it is not dissipative. Okay, I hope that was enough of an explanation. Now, where are we? Okay, so let's go back to the cart. What have I got in the cart? Why have I got two things in there? One item. Come on, view cart. Come on, show me the cart. I must have had something in there previously waiting to go. Unless JLC is just confused. Ooh, okay, no, I've got other things. All right, so that's other stuff for a customer. Reorder. Now, what happens? Watch what happens if we edit this order. So this is exactly how I ordered it. It's green 1.2 millimeter lead-free hassle, and it was 5 panels. Each panel was a 4x8 matrix, so 32 PCBs per panel. So a total of 160 modules. Okay, and it was $73.65. So you can see this PCB quantity here. You see how it says 5? It's actually 5 panels of 32 PCBs per panel. So $73.65. Keep that in mind. If I edit this order, let's see what happens if I start messing around with some of these parameters. So we've got 95. Oh, that 73, was that US dollars? I don't know. So engineering fee, $37 engineering fee. Surface finish, 7.72 because I've gone for the lead-free hassle. They charge more for lead-free, which is annoying. Isn't sad? Get this. Okay, the boards are costing $6.79. Then you add on a $37 engineering fee, a $7.72 surface finish fee, a $22 fee for V-cuts because the boards are so small. So these boards are 12 millimeters by 20 millimeters. They're quite small. So there's an extra $22 for that. There is a stencil. Oh, okay, let's get rid of the stencil. Can I get rid of the stencil? Framework, stencil, where's the stencil? Advanced options, hassle with lead. Anyway, doesn't matter. That's the difference. That's why it's $95 instead of the 73. It's because the stencil is included in this price. Let's just change the color from green to blue and see what happens. So it's just gone from $93 to $153, including the stencil. What happens if we go to yellow on the PCB? It has now gone to $178. Red, I think red, purple, and yellow are all the same price. 153, so it's cheaper on red. Yeah, yellow is a pain in the ass color for them to make, for reasons I won't go into right now. I've had yellow PCBs made in the past, and it is actually really hard to make a yellow PCB for technical reasons. Basically, yellow paint ends up nearly translucent unless you pre-coat the underlying board with like a titanium finished, like a white first, as a blanking layer. So 152 for white.
Yellow is so
black?
worth the extra cost.
It does look good sometimes, but it can be a real problem. It can end up looking really washed out and show all of your tracks through it, and then it really just doesn't provide a nice coverage. Or it can end up, one of the problems is if they try to make the yellow formulation have good coverage, the way they achieve that is by adding a bit of titanium powder to the paint and some other things. And the problem with titanium, adding the titanium to the paint, so I used to work in a paint factory, by the way. Back in my uni days, I worked at the paint factory in Bayswater and at their various retail stores. So if you add titanium to paint, it increases its opacity, which means that it reflects from the paint itself rather than the light going through it and then reflecting off the underlying surface. But it also reduces the intensity of the color. And so if you add titanium powder to a yellow paint, it becomes more translucent, but it also becomes more washed out. And the way they counteract that is they add another coloring agent to it, which then has the effect of making it warmer. So the risk you run is you have to run it to get your formulation right to make yellow paint, is you are balancing a line between making the paint look like a really pale yellow or making it look like an egg yolk. And if there is too much titanium, it ends up looking like like really pale. If there isn't enough titanium, it ends up translucent, and you can see the color of the underlying thing coming through. If you have more of the other additive, it ends up looking like verging towards orange and more like an egg yolk sort of color rather than what you would consider to be like a really nice yellow color. So yeah, making yellow paint is hard. It's not one of those things you would expect. It doesn't sound like it should be hard. It is hard. So that is typically why, like black here, got $157. Yellow, 190, oh, what was it, 178 for those boards. Yeah, to do it right, if you want to get a really beautiful looking yellow finish on a PCB, they have to do it as a two-step process. What they do first is coat with white. So you get a white silkscreen, and then you coat with yellow over the white as a second process. So it's a double step process, and that's why yellow costs more than all these other colors. So purple, yeah, Imi loves purple, said Crispian. Yes, purple PCBs, but they are also $153. So if we just go for green, oh, and also fastest turnaround. These take 2 days longer because their batches are less frequent. They cost more and stuff. Wagon loads. Quote, I fell into yellow. Where does that come from? That's a movie quote that I'm not familiar with. I wonder if it's something I've seen. So, wagon loads. Where is that quote from? I fell into yellow. Please share. Yeah, so the result of all of this is Crispian says yellow is better than yellow. Yeah. I know exactly what you mean. Yes. If you were around in the 80s, 90s, then yeah. Oh, Wagon Load says Mad, Mad, Mad World. Yeah, I haven't seen that. So that's why I don't think I've come across that quote. Yellow, Homer Simpson. What? Okay. Yellow jelly. I don't know. I'm losing the plot here momentarily. So, okay. Now this all came about from the question of why not just make the PCBs different colors in the silkscreen when ordering. So the two reasons. Firstly, it's more expensive. They take longer to produce. That's and it is still limited because yes, there are places that will do full color, like multicolor silkscreen, but at the moment this is just whatever color. Like if I pick, for example, green, then I'm going to get white text on it, and I don't have any say in the matter when it comes to it. If I went to other places, like I think All PCB and PCB Way, might be some other PCB fabricators who when you pick the PCB color, and then from the PCB color, you also independently pick the silkscreen color. So I could say, I want green PCB with black silkscreen, or green PCB with white silkscreen, and they'll do it for you. And there are also places that will do full color silkscreen printing, which is no longer actually a silkscreen, it's an inkjet, but anyway, that's a whole other thing. We still call it silkscreen, even though this is typically done with a digital inkjet type process these days in modern fabs. It's the old terminology, even though there is no silk and there is no screen. So so here we've got white as the silkscreen color, and we can't change it. If I click on purple, still only white. What happens if I go for yellow? Do I get a choice of silkscreens? No, it's going to be white. What happens if I pick white? It's going to be black. Yeah, so they've got the option here for selecting the silkscreen color, but they only give you one option. They basically have pre-selected the matching silkscreen color that is a high contrast against the PCB color or the solder mask color that you've selected. What is it? Oh, okay, so they use white on red. So they use white in almost all situations. I suspect these will all be white except for yellow. So white solder mask. Oh, sorry, white silkscreen on all of these PCB colors, except that on white they use black silkscreen, and on yellow they use white as well. Wow, you're not going to be able to read that. When I've had yellow PCBs done in the past, they've put black silkscreen on it because there is no contrast between white and yellow. But yeah, you really need black silkscreen to go on yellow solder mask. Crispian says, we aim to make you lose the plot. Yes. And you invariably succeed. Don is leaving us. See you, Don. Thanks for coming along to the stream. And also, congratulations on selling a house, congratulations on buying a house, and congratulations on having 2 jobs to choose from. So, it sounds like everything is coming up, Don. Yeah, it's good to hear. It's good to hear, Don. So, yes. Right. And so let's get out of that. So the other thing is that it just allows me to do so much more. I can go full, I can exercise what tiny little bit of artistic expression that I have in doing things like red labels or red backgrounds for the power rails, black on the ground pins. I can do white labels against the black and the red. I can do black against the yellow. I can put a link on the back which is blue and underlined to make it look like a link. So yeah, rather than doing a colored PCB, I think this is going to end up looking a whole lot better. But I do need, okay, so this is where I think I need to get these printed as proper stickers, and that is durability. This one that I was just waving around under, this shows you how small these things are. This one that I was just waving around under the camera before, this is printed on, oops, I'll switch to that view. This is printed on just regular paper, came out of my laser printer. So I've got a color laser printer, which is good. So if I can find a material to print on with the color laser printer, that would be ideal, because then I could print them myself. I need something like an A4 sticker sheet. The problem is, I do have A4 sticker sheets. The problem is that they have a matte finish and the laser printer doesn't bond very well to them. So the toner sort of flakes off. And I'm pretty sure that's a temperature setting. Like, it's a problem with the temperature of the fuser, like when it's trying to fuse the toner onto the paper. But on here, because I have bent this around, the paper is already fraying right here on the edge. I'll use my, is this lead free? No, this is the leaded solder. No, lead free, yeah, silver, yeah. This is my lead free solder. So the edge of it is frayed just here. You can actually see on camera there's a white line there. That should be all continuous black because it was bent around, and it's frayed here. The just regular office paper is not strong enough for this sort of thing. It needs to be something that is like a glossy, durable finish, like a sticker. So I think if I lay out a bunch of these side by side, to however many make sense. Essentially, I want to panelize these and then have them printed as a sticker, just on an off-the-shelf sticker size, whatever standard things you can get. Then I can just cut them up and apply them. And I think I'll end up with something that is durable. Hopefully the print quality is good, and it should look good and last well. So anyway, that's yet another side quest that I have just been playing with. But if anybody has suggestions about laser printerable sticker material that is glossy, that you've had good experiences with, I would really love to hear about it. Oh, Imi says you should be able to get sticky paper specially for laser printers and possible heat vinyl. Yeah, I have looked. Officeworks has some, and it's very expensive, and the reviews say it's terrible. So it makes me a little bit worried. UV printer. So where is it? Where is that UV printer project that was on Kickstarter recently? Make. Here we go. So things like this, something like this would be very interesting as well. I've wanted a UV printer for quite a while. And this one, where is it up to? This thing's been all over YouTube in the maker community for a little while now. So the with this you can print onto physical objects with UV cured stuff. So let me find an example. Creative ideas. Yeah, so people print onto bottles and placemats and all sorts of things. Yeah, lots of YouTubers. They've seeded these printers out to YouTubers. And there was one, that's right, Robin, the dude who did the Pixel Pump, had a really interesting thing about this. This is actually cool. I'm going to find this. Pixel Pump, UV printer. Here we go. I'm not going to play this whole video. I'm going to open it and then pause it so that I don't get demonetized, and then just show you some things. So Pixel Pump is a thing for picking up surface mount parts when you're doing assembly. And where are we? So this is the Make UV printer, and the basic problem is that he wanted to print onto, I've got to find you you can go and watch this video yourself. But the issue is he wanted to print onto these odd shaped things, which are the SMT part reels. I'll find an end result. Where are we? Here we go. So what he did was modify the Make to add a couple of big buttons on the top, and you can see there's a box here sitting on it. That is a box with a little servo thing in it with a finger arm that sticks out and presses the start button. So what he can do is he's got a template which is 3D printed, that all of the the things drop into. So he sets up an array of these parts, and then, yeah, there you can see. So that is on the little tray that holds them all. And then it's kind of a nasty, hacky approach. But what he's got is these buttons for 12mm and 16mm output. And what it does is when you press the button, it runs somewhere. So sitting on a computer over the other side of the room, I want to find it, is, oh yeah, there's the thing that presses the start button. He's basically remote driving a Windows program. No, I'm not going to find it. All right, but the software that runs this printer has no API. So you can't do things like from a script, tell it to load a job and then run the print. So what he's got is a like an accessibility thing. He's got a Windows computer running with the UFIMake software on it, and then the accessibility software is moving the cursor around and clicking on buttons on the screen to start the print jobs and make it do different things. So when he, for example, presses the 12mm button, it means that he wants to run a print job of the 12mm labels on the things that are loaded into the printer. So he presses, all he does is press 12mm. That then sends a signal to the computer, which is running the UFI software, and it moves the cursor around and clicks on things on the screen to select the correct options in the software, and then it sends the print job to the printer, and then it fires the relay in this box to push the button on the printer, which is the start button, so that it actually starts the job. So it's like this, what's the term for the contraptions? The you know, when you take a whole lot of, I've gone blank on the term. There was a name. There was someone who did these, built complex contraptions where one thing would do another thing. Yeah, the answer is probably Rube Goldberg. Yes. So it's a Rube Goldberg machine to to run his UFIMake printer, because there is no API for it to be able to do this programmatically. But it's a very clever, nasty hack. Wagonload says, you made me come up with a new project. Use a JSON-controlled servo to start my coffee maker. No, hack the coffee maker. Come on, there's got to be a button on there. So personally, all right, so what Robin has done here is he has adhered a thing on the outside of the machine that physically presses the button. What I would have done is open the machine and wired a relay or similar across the the contacts for the button. But maybe you can't get the machine open. I'm not sure. Maybe it has to be done physically from the outside. But if there's a button on a machine, you can usually hack it so that you can remote control it with Testomatic or something. Often the simple answer is something like a Wemos D1 Mini with a relay output and Testomatic, because then you can fire that relay with MQTT or, yeah, whatever you like. Yeah, so people were talking about, where was it? Someone mentioned a vinyl cutter. Oh yeah, so Stephen said it may be better to get someone with a vinyl printer and plotter to print and cut them. Yeah, that sort of thing. Oh, and Simon says you could possibly just use a spray-on sealer before applying them. That's true. Like spray, I've got clear spray, like in a spray can that I could put onto the paper. That might work. Or it could even be after applying them. Print on mica, suggested Crispian. Not sure about that. I don't know if it would bend well. Grant says, spent ages with fuser setting when we changed laser printers that printed pallet labels Turns out that the stickers are much higher GSM and require a higher fuser temperature. Yes, exactly. That is, I am pretty sure that is my problem. So what happens is that when I print onto the stickers, onto the sticker label paper, it the toner just sort of comes off. It flakes off, and it can actually get stuck on the fuser drum, and bad things happen. So firstly, the print comes out looking terrible. Secondly, it is not durable. So what is there you can sort of just rub off with your fingers. And thirdly, it can end up on the drum in the printer, and then the next piece of paper that comes out can have bits of that toner stuck on it. So it's all bad. And I have played around with the printer settings. Like, I've told it that it is heavyweight paper, which in theory increases the temperature on the fuser drum, and it still does the same thing. So it could just be limitations of my particular laser printer, whatever it is. I think it's a Samsung thingamajiggy. Yeah, I've played around with that a little bit, but not enough. It's one of those things where it has annoyed me enough that I have tried to solve it. I've put a little bit of time into solving it, but it hasn't annoyed me so much that I've just said, screw this, I am fixing this problem no matter what it takes, and then just sitting there and going through and trying to solve it. So yeah, it hasn't got to that level of annoyance because I print stickers so infrequently. Wagon Load says, use a servo to press the reset button on your ESP32. Yeah, and control that servo from the ESP32. So basically, you'd built a useless machine at that point. Okay. Run the paper through a fuser used for laminating plastic, says Mr. Fixit. Well, maybe, but the problem is you've got to get the toner onto the paper in the first place, and a lot of it just doesn't end up on the paper. It ends up staying inside the printer because it doesn't even fuse enough to stay on the paper. Yeah. So, material-wise, that is where I'm at. I've, what should I say? Where are we? Kickstarter, Eufy Make. Yeah, so one of these printers, yeah, I would really like to have a full-color UV printer, because that would just make this whole problem go away. I could just print straight onto the little plastic caps. I'm not sure what the resolution of this would be though. Whether it's as good as, I don't think it could be as good as printing onto like a perfectly smooth sticker surface. Because if you're printing on a sticker, you're dealing with a very, very flat surface, and you can get very high resolution, fine detail. If you are printing onto plastic with UV cured ink, I don't think it's ever going to achieve that same degree of precision. Grant says you could just stick contact book cover over the laser print output. Yeah, yes, I have thought about that as well. So that is another option. Wagonline says, would photo paper work for labels? I've thought about that. The problem is that photo paper does not take kindly to being bent, and it tends to flake because the substrate, so photo paper has a very, very smooth mirror finish, but then underneath that, it typically has larger flakes, which are the mechanical substrate layer. And when you bend it, those flakes don't like being bent, and so it frays along joints. If you take a piece of photo paper and bend it, it doesn't last very well. It doesn't last nicely. So, yeah. So anyway, a printer like this could be a good option, but I still think that my idea of some kind of a sticker-based label like this is going to give good results. I think it's. I have to keep telling myself that this doesn't even matter. This is a side quest. I could make all of these modules the same color and just not care. And they say what they are. I am trying to solve a problem that isn't a problem, is what it comes down to. I am inventing a problem for myself to solve, and then I'm off on this side quest with little 3D printed caps going onto it and then stickers that wrap around it, and it's all just so I can make them look pretty. Why do I do this to myself? It's not even the thing that matters. Crispian says there's nothing wrong with perfectionism. Yeah, but I need to find the balance. There is the balance where perfect becomes the enemy of the good. Or rather, perfect is the enemy of done. Whatever the saying is. If you keep chasing perfection, you never actually get the thing done. And I need to just make this thing work. Make it work, then make it pretty. Not make it pretty before it works. So, Wagon Load says, can you CNC engrave the caps, then fill the grooves with paint? Technically, possibly yes, but the resolution would be ridiculous. So keep in mind that this whole thing is 12 millimeters wide. This text, what size is this text? It is, I think, 3.5 point. If I do, let's see, if I do that and that. Oh, that is 4.5 point, 4.5 point. What? How high? Blah. 4.5 point font height. In millimeters, let's see. It is approximately 1.6 millimeters high. So that entire character is 1.6 millimeters high. The resolution on that you would require, like you can print this and it comes out. If you print this on a nice media, it will come out looking nice and sharp and clean. If you tried to CNC machine a feature that small, where the width of this is like 0.2 of a millimeter, yeah, I don't think you'll achieve it. And then imagine trying to fill that with paint. You've got, yeah, you got to put these things under a microscope to to really deal with them. So they are small. They are small. Real size. Real size. I'm going to look at the screen. Okay, on my 27-inch monitor, that is now zoomed to be approximately 1-to-1 size. Where are we? Is there a, in fact, is there a zoom? Where are we? View, zoom. If I zoom to 100%, oh, okay, it thinks that's what 100% is, but that depends on your monitor size. Physically, no, that is way bigger than 100% on this monitor. It is, on a 27-inch monitor, that is approximately 100% scale. So these things are small. It gives you a totally warped perspective when you're looking at them like this. Grant says, on acrylic I engrave using stick fonts, then colour with a whiteboard marker which will wipe off the non-engraved surface and sticks in the grooves. Oh, that's cool. Crispian says 55-inch display here, they look large. Tinker says, oh, you need to add a QR code to the labels too. You are absolutely right. I should put a QR code on the back with a link to Testomatic.io, which at the moment I think just goes to the Superhouse site, but I want to set it up as a dedicated site just for Testomatic. One idea, can you make it out of flex PCB? The whole PCB is ground, then you can connect it to the real ground. It would be a nice shield. I don't understand. Make it out of flex PCB. The whole PCB is ground, then you connect it to the real ground. Oh, I see. Oh, Grant says put the QR code on the end. Yeah, but the end is only 4 millimeters high. I wouldn't be able to fit a QR code into that space. Yeah, a Faraday shield. Yeah, oh, I see what you're saying. Yeah, so flex PCB, wrap it around. Yeah, I don't think it's necessary though. Yeah, that gap, that bit there, which is that is the bit that sits on the end, that is only 4mm total. Ah, no, QR code on the front to scan and see which model it is and any configuration data. Oh, okay, yeah, so fit one in here somewhere or in there. Yeah, I wonder if I could fit that. So that is 6.5. Yeah, the QR code would need to fit within about 4mm by 4mm to fit in there, unless I remove this big fat label that goes on the front. Yeah, in any case, I don't think it's all that necessary. One thing that oh, Spicy asked, could I check how much Flex costs right now? No, I'm not going to, because I would need to create a design and upload it in order to get a quote on it. I can't just change an existing design to a Flex PCB. So it'd be quite an exercise to do that. That's not like a 1 minute thing. And also, I think a Flex PCB is an interesting idea, but it would not solve my problem of all of this labeling. Now, so I was thinking about the URL on here. Thinking about the site, the Testomatic.io site, which does not yet exist, is going to have information about the I/O modules and everything else, about the chassis, about the software, about how to design your own test modules. Like, it's going to have a lot of documentation on it, and I would like to be able to put a URL on here. Maybe what I should do is change this. So I'll make it testomatic.io/AD and just make that as a, let's decrease it. So instead of 7 point, let's make it a 6 point thing. So make the URL specific to the, so this would be 8B, basically like a shortened URL that can then redirect to, well, that would be /20. What would I use as the short for that one? MCP? Yeah, I think so, probably. So that one would be /MCP. Will 6 point even fit? Yes, it does. And then if we have an SPI versus an I2C version, they would probably end up on the same page. So that one would also be MCP. Yeah. So then there is a specific URL on the module itself, which can go to the info page for that module. I think that's better than just dumping people on the home page and letting them navigate their way through the site. So yeah, I need some little short extensions. What would be nice is if I had a shorter URL, like I don't know, tmtc.io, something like that, and then I could do really short URLs to go to specific pages, and they can go on these tiny little labels. Wagonload says, would it work if you could make the IOMODs in a micro SD form factor? I don't think there are enough pins. And also I think it would end up taking up too much physical space on the board because of the way the cages work. Yeah, I don't think, mechanically I think it would be a problem. I think having these as DIP format that plug in, TSMC should be available, says Grant. TSMC. I highly doubt anything TSMC related is available. But yeah, now that I'm thinking about it, I think I will go looking for URLs that I can use as a URL shortener, because I've got tron.cc as a URL shortener for Freetronics, so that I can put URLs on boards like tron.cc/ndrive, and I can generate fairly short URLs, which are good, better for QR codes. The shorter it is, the simpler the QR code can be. Okay, so Wagon Loads, where was it? Tinker said, could make the caps taller to give more room for the QR code on the end. Yes, exactly. I had thought about that. What I could do is make these just physically thicker. Just print the caps thicker, and then the ends become bigger. Yes, that is definitely possible. However, I don't think it's really necessary in terms of getting a QR code on there. Maybe what I should do is have a label on the end. No, it's pretty obvious. If you're looking inside the Testomatic and you see modules plugged in, if they're all different colors and there is this big label on it where it says MCP 23008, it's pretty obvious what it is. When they are inside the tester, the top part of the module is very obvious and easily accessible. So labels that are on this top part are right there in your face when you're looking into the tester chassis. So I think having it just say on the top what it is enough. And if people are setting up for the first time and learning all of this and figuring it out, having the URL on the bottom is fine, because you'll have the modules in your hand. You can look at it and go, ooh, where's the info for this? So, and if failing that, if you've already got it plugged into the chassis, you're probably going to be looking at the testomatic.io site for documentation anyway. So yeah, I think it's chasing a it's a side quest off a side quest that doesn't need to be solved. Jack's Tech said, just use a cardboard spacer. You can laser cut them incredibly quickly. And Simon says, overthinking it all again. These things will only ever be used by people that understand electronics, since they're going to be testing things. Yeah, that's right. The audience for this is very different. Which reminds me, okay, I am now, whoa, I am seriously over time. I did not realize I was that over time. I'm going to, before I go, I'm going to show you something, because by a fortuitous thing happened last night. I was trying to sleep. I was in bed trying to sleep, and I was distracting myself from being unable to sleep by chatting in Discord. I was on the Opulo Discord for the Lumen PNP, and I'm sure most of you have heard me mention that before. So in the Opulo Discord, someone was having a problem. Someone's doing burnouts out the front. Someone was having a problem because they had built some prototypes of a particular board for a client, and the client was wanting to, like, I'm only going to reveal what's already been revealed in Discord anyway, so I'm not breaking any confidences with this. So what they did was order some prototypes of this board, like 5 of them or however many, from JLC PCB with an assembly service. And the assembled boards came back, and he plugged in a programmer to flash a bootloader onto them for testing, and he couldn't flash them. They've got an 18 mega on them. So you got a USB ASP, an ICSP programmer, plugged it in, hit burn bootloader in Arduino IDE, and it failed. The micro did not respond. Tried with a couple, they all failed. And so then in frustration, he removed the micro from the board, and he took a micro from another board that he knew was working and put it on, and it worked. Theoretically identical micros. They are both 18 megas, both the same, and one of them he could flash, the other one he couldn't. The one that came from JLC PCB, loaded onto the board as part of their assembly service, he could not flash it. He could not set the bootloader. Could not install the bootloader. And so Anyway, he was on the Opulo Discord in the electronics channel asking about this problem. And so I suggested that the problem was that the one that he substituted in, which had previously been working in a board, had its fuses set so that it would allow full speed ICSP programming. Yeah, Simon asked fake chips. Well, that's one of the things. But the thing is that was one of the options, and the worry is, okay, you've got this batch of things that came from JLC, and you can't flash them. But JLC should be a reputable place to get parts from. If JLC was putting fake parts on boards, that would be a serious problem to their reputation. And I think they would work very hard to not have that happen. So, but that was one of the possibilities. So, yeah, I made this suggestion that the problem was that the fuses on the parts that came from JLC were factory default. And the factory default settings on an ATmega processor put it into a slow internal clock mode, and you can't communicate with it at high speed. You have to pull your ICSP programmer back down to a very low programming speed in order to be able to communicate with it, because it's running like maybe in the kilohertz region or something. It's really slow. Like, it's just using a little internal oscillator at a very low speed. So I suggested checking whether he could burn the bootloader or burn the fuses by putting the programmer into low speed mode. And the long and the short of it is that did turn out to be the problem. The chips were fine. Once he had a programmer that was in low speed mode, he could burn them, and it all worked fine. So anyway, the point is, we'd had this little conversation. We've been going a little bit backwards and forwards on Discord, on the Opulo Discord. And then he sent me a link of this. And also has joined the Superhouse Discord. So some of you have already been chatting with Vermatis, Nicholas Chaslow. So the username Vermatis on Discord. And this is a project from a year ago to make the Universal Mid-Scale Manufacturing Test Jig, the UMMTJ. And this seems so familiar. The problems that Vermatis is trying to solve and the approach is quite similar to the way I've been going about it. And the description even, it's an open source programmer and test jig designed to simplify the life of small electronic manufacturing companies. Automated programming and testing of boards and panels. So it's a jig with SDKs designed to operate it, turnkey solution with hardware, software and processes to simplify the design, build and use of a production-ready prog and test jig. And this you can see here a render of part of the chassis. So the way this design works, let's see if, can I zoom into there? Yeah, so these are 2x20 pin headers. And the idea is that his version of a test module sits down onto those pin headers, and that's where the signals come through from the board underneath that is running the tests. So if you want to swap your test module, your pogo pin board, the TPCB, plugs in vertically into these headers. So what this is achieving is the same thing as we are achieving on the Testomatic with the PCI edge connector, with the board sliding in horizontally instead of going down vertically. But the fundamental idea is the same. You have a board which runs the tests and has a whole bunch of I/O on it, and then you have a module that plugs in which provides the specific breakout for the device under test. And you can see up here there is this mechanism which pushes down from above. So this is part of the pressure plate support mechanism. And yeah, so anyway, what we are trying to achieve at the end of the day is essentially the same thing. And the method by which we are going about it is kind of similar as well. So Vermatis has now joined the Superhouse Discord and has posted a link to this in the Testomatic channel. So if you're interested in seeing what he's done with his thing, go and have a look. Oh, which reminds me, what I should do is this. I haven't posted this for a while. If anyone is wanting to join the Superhouse Discord, go with that. Yeah, so Mitchell says, I'm so glad you went PCI connector over pin headers. Yeah. So one of the things that Vermatis said is that he's not happy with the force required to add and remove the test modules, because you've got, essentially it's like the pins of a Raspberry Pi, but two of them. So the Raspberry Pi is a 2 by, what is it, a 2 by 20, 2 by 40, 2 by, whatever it is. So imagine two Raspberry Pi pin headers. That's, yeah, 2 by 40, I think. It can't be that long. Anyway, I can't remember. Someone will tell me. Anyway, imagine you are trying to plug in two of those at the same time and keep it all straight and things. So there's a fair bit of force in getting the test module in, and then a fair bit of force getting it out without damaging it. 40 pins, 2 by 20. Okay, yeah. And Lachlan says 2 by 13. So 2 by 13 is the old Raspberry Pi format, and then they extended it and it's now 2 by 20. So 40 pins, 2 by 20, says Grant. Okay. So 40 pin headers is what is on this. It's the equivalent of 2 Raspberry Pi hat headers. Yeah, so that is one of the difficulties that he's run into with this design. It's just the force involved in that. Oh, I didn't mean to click on that. But still, it is cool. Schematic progress. Mainboard mockup. Moving forward with the CAD thing. Is there a, oh yeah, so this is, oh, KiCad. Oh, there's a step. Let's see if it'll render in the browser. View raw? No, oh, it's too big. Okay. Mainboard, let's have a look, see if there's a step for that one. Is there a step file? No, I can't see it. So, yeah, anyway, it is really cool to see Vermatis working on this, and maybe we can learn from each other's approaches, and we can, yeah. Oh, Lachlan says Samtech do low insertion force versions of many 0.1 inch. Yeah, that's true. You could use a ZIF socket, and then, so you drop it in and then pull the lever down and latch it in place. I still think my edge connector version is cool though. I like that. I like the way that has worked out. Not that it was my idea. Someone else suggested it. I have a feeling it might have been Austin or somebody. I'm pretty sure it was not me who came up with the idea of using the edge connector. Oh, Lachlan says not ZIF, just lower force. Yeah, okay. So low force, not real ZIF. Yeah, so I'm now heading towards an hour overtime. Nearly 3 hours on this stream. My jaw is hurting from talking this much. So anyway, that was a cool thing that happened last night, was running across Vermatis on the Opulo Discord, and I've now joined his Discord, and he's now joined the Superhouse Discord. So if you see Vermatis in the Testomatic channel, say hi, and check out the work that he's already done on this. Yes, so that is cool. Right. I think I should go. Now, oh, before I go, I've now done nearly 3 hours of just talking and not actually doing anything. I actually had dreams today. I had goals, I had dreams, I had aspirations, because this arrived yesterday, day before. I'm pretty sure yesterday there was a. Oh no, that was boxes. This would have arrived Friday. This is a programmer for the CH3F. I don't know that part. I need to get that part number in my head. The 10-cent microcontroller. So I said I've still got 10 minutes before the F1. Crispian says, aren't you getting sick of us? No. So this is a programmer for the 10-cent microcontroller. So this is what should allow me now to put Jonathan Broadwell's firmware on. Thank you, Stephen. CH32V003. I've got to get that right. CH3V003. This is a programmer for it. So now I can put his firmware onto it and get the serial Wombat versions of the IO modules working. What you saw me doing right there, taking it out of the bag, that is the first time I've taken it out of the bag. Haven't plugged it in, haven't tried it yet. I don't even know what the process is. I don't know what software I need. I may need a Windows machine running, which would be a pain. I just don't know. So one thing that I had thought of doing for today's stream was plugging this in, getting the software set up for it, and trying to load firmware onto one of those serial Wombat. I will refer to Stephen's cheat guide, CH32V003 based IOMODs. But I haven't. I didn't get to it. Wagonload says 3 hours is short. I've done 6-hour chats with AI to design something. Yeah. I don't have the energy. It has already been a very tiring weekend. I am zonked. And I have a lot more to do this weekend. So I'm not going to continue for another 3 hours and do this on stream. I am going to crash out, get something to eat, have a rest, and maybe try getting some firmware onto one of these modules. Oh, Amanda said, today while watching the stream I've started and almost finished my next assignment for uni. You can keep going, I'm having a productive day. Yeah, okay. So I am the noise in the background that allows you to concentrate and work. Good job being productive. Keep it up, Amanda. Crispian asked, how are your lungs? Did you clear the pneumonia? I still have a little bit of a cough. It is very close. I did Muay Thai yesterday, and apart from being out of shape, because I have done very little training over the last couple of months while I've been dealing with these health issues, I hung together okay. I actually survived. I got to the end of the sparring sessions and I still felt alive. I could still move. I wasn't falling over, so that's good. Last ever sparring session was with my friend David, and he took it easy on me. So yeah, got through it pretty well. Yeah. So I'm going to go. Thanks for hanging around. Thanks for sticking with me for a nearly 3-hour stream. Yeah, on the side issue with that, of course, is that summer is coming up. The good diving weather is nearly here, and I want to be able to get back in the water. I don't want my my lung issues to be a problem, so I'm glad that that is pretty much behind me now. But I need to make sure that I'm in good shape and that I can breathe before I go back in the water next. I will be sensible about that. I'm not going to dive if there is a question about the state of my lungs. I will do that when I know I'm healthy, which I pretty much am now. Unfit, but kind of healthy again. So yeah, thanks for coming along. Thanks for all of the nerd brags. They were good to see, and have a really good week. And I will see you next week. Thanks. Bye.